Welcome everyone to the Aldehydes and Ketones unit. We are going to go through what I think are the three big picture things about aldehydes and ketones that you need to keep in mind as you are venturing through all of this material. But first off, we have the structures here in front of you. Just as a reminder, aldehydes have a hydrogen hanging off, and ketones have two carbon groups hanging off of the C double bond O. And so, one of the big picture things we've already talked about in the overall OChem 2 big picture topics, but it's worth a reminder as we dive into it. So, aldehydes and ketones have no leaving group attached to your carbonyl. So, this is a big deal, and this is really important because the thing that all of these reactions are going to have in common, if you have a C double bond O, here I'm going to use a ketone for this one just as our example, but it would be the exact same thing for an aldehyde. If you have a nucleophile, like we know, nucleophiles attack C double bond O's at the carbon and kick this up. And as a result, because these don't have a leaving group, either here or here, so carbon groups or hydrogens cannot leave from the molecule. What you end up getting with a lot of these reactions, not all of them, but a lot of them, is you get something that looks like this, where the nucleophile is attached and you keep the two original groups that you started with. And so this is a general feature with everything. What you're going to see as you go through the reactions is you're not going to get exactly this right here. As you're going through the reaction, you may get something a little different. But in the mechanism, at some point, for nearly every reaction that we are going to cover, you are going to have something like this. So that's big picture, big picture thing one. Big picture thing two that I want you to keep in mind, and this is really, really important. Aldehydes, they are more reactive than ketones. So aldehydes are more reactive than ketones, and let's explain why really quickly. So let's take a look at their structure right here, and what I want you to notice is aldehydes have one carbon group and then a hydrogen. Ketones have two carbon groups. And something that you learned in OChem 1 is that carbon groups take up a lot of space. And so, since with the ketone you have more carbon groups surrounding it, surrounding the C double bond O, this C double bond O on the ketone is more crowded and less vulnerable to attack than the aldehyde. Okay, so sometimes professors will harp on this. Sometimes they'll just talk about it for about 5 minutes and then that's it. But I wanted you to have it right at the beginning that aldehydes are more reactive than ketones, and it has to do mainly with sterics. There's also an electronic factor to it. I'm just going to show that to you really, really quickly because I'd say some professors are sticklers about this. So let's just talk about this really quickly. Okay, so with this being said, both of these, what you know about C double bond O's is that this has a partial positive charge right here, the carbon. And it's because of that resonance structure. So there's a partial positive charge on that carbon right there. So therefore, like we've talked about, if you have a nucleophile, in both of the cases, the nucleophile is going to attack at the carbon, right? Okay, so with that being said, what I want you to know is that carbon groups tend to donate negative charge. So the aldehyde only has one carbon group donating negative charge. The ketone has two carbon groups donating negative charge. And so therefore, the ketone has a less electropositive, it's a less positive C double bond O. And the reason why is because those carbon groups are donating negative charge right there. So there's also an electronic factor to it. So the ketone, it's a double whammy. Ketones are less reactive than aldehydes because of the crowded R groups that are surrounding it, and because those R groups donate negative charge and make that C double bond O less positive. Okay, so with that being said, since aldehydes are more reactive than ketones, if you have one of each on a molecule, so let's say I gave you this molecule right here, and there's a ketone on one end, and there's an aldehyde on the other end, and you had 1 mole of let me give you a reaction that you're going to see in this. You're going to see this reaction later. So based on that concept, if you have a ketone and aldehyde in the same molecule, since aldehydes are more reactive than ketones, this aldehyde will react preferentially over this ketone. So you can control where the molecule that's incoming goes if it reacts potentially with both. So what you're going to get here, you're going to see this quite a bit later on in the unit, in the problems, but you get the aldehyde reacts instead of the ketone. So that is the second thing. The third thing that I always want you to keep in mind is the aldehyde hydrogen is untouchable. Okay, so I misspelled that. Okay, it's untouchable. So what I want you to think about, students get, I'm introducing this to you early. Students get tempted to rip this hydrogen off on the aldehyde. Because bases love hydrogen, bases want hydrogen, but they cannot grab hydrogen from an aldehyde. The aldehyde hydrogen is there to stay. No matter what, in all the reactions that you are going to see, if you track it, this hydrogen on the aldehyde is going to stick no matter what throughout the rest of the course. So whenever you see an aldehyde, don't mess with the hydrogen and you'll be good. So just keep that in mind. That's pretty much it for the big three things that I want you to keep track of. We're going to dive into the reactions in detail, and I'll see you there.